Displacement time graphs are used to represent objects that are moving. This will also bring in kinematic equations to work out the exact values to be plotted. Displacement is placed on the y-axis, whereas time will be placed on the x-axis. The gradient of a displacement time graph represents the velocity. On a distant time graph, the value of acceleration is the rate of change of the gradient, and so acceleration is the rate of change of velocity. For graphs of displacement time, a constantly accelerating object will produce a curve. If the object has uniform acceleration, which means a constant acceleration, then the gradient will remain constant. Acceleration is shown by a curve with an increasing gradient, and deceleration is shown by a curve with a decreasing gradient. To find the value of velocity on a distance time graph, it is the change in y divided by the change in x. If the gradient is not constant, it shows how the object's velocity is constantly changing. To work out the velocity, simply draw a tangent at a point and work out the gradient of the tangent. Or, for more accurate results, you could work out the equation of the line and use differentiation to work out the gradient, and in which case velocity, for that point. The gradient of velocity time graph represents acceleration. The steeper the gradient, the greater the acceleration, whereas a straight line will represent uniform acceleration. Again, uniform means constant. To find displacement is all about the actual lines. Velocity time graphs can have negative regions, unlike speed time graphs. This is because the negative region shows something travelling in the opposite direction. Because velocity is a vector, so it has magnitude, which means size, and direction. The area under the curve can be used to find the total displacement travelled. This is done by working out the area under the curve. When the acceleration is changing, the gradient of the graph will be constantly changing. Increasing acceleration is represented by an increasing gradient, whereas a decreasing acceleration is demonstrated by a decreasing gradient. The acceleration value of an object is represented by its height on the graph. If the line is within the positive acceleration section, the object is increasing its speed. If the line within the negative acceleration section, then the object is slowing down. If the line is at 0, then the object is going to be moving with a constant velocity. To find the velocity on an acceleration time graph, find the area under the graph.